This is the first question we are going to evaluate. Let us evaluate the integral from 0 to infinity of x squared times e to the power of minus 2x dx. This is a question under gamma function. The gamma function of x is the integral from 0 to infinity of t to the power of x minus 1, okay, times e to the power of minus t dt. This is the relation for the gamma function of x. The x you can see here is the t we have here, all right? So this integral now, let's look for a way to write it in this format. The integral from 0 to infinity of x squared e to the power of minus 2x dx. I can see from here, the gamma function of x, that e is raised to the power of minus t. T is having a coefficient of minus 1. But here, x is having a coefficient of what? Minus 2. So we have to make a little adjustment. This is it. I will say, let u, all right, I'm introducing a new variable now. Let u be equal to this 2x. And this implies that if I make x the subject of the formula, x is equal to what? U upon 2. Let's keep that. From here, if I differentiate u with respect to x, that's du, I will obtain du equal to what? 2 dx. Differentiate u with respect to x, this is what we have from here. Differentiate this du, and this is what? 2 dx. So, if I make ds the subject of the formula from here, ds is equal to du all over 2. What we are trying to do now is to express this integral as a function of u, no longer x. So this limit, this is x equal to 0, x equal to infinity, all right? So let us see what u is when x is 0 and when x is infinity. So when x is equal to 0, what's u? Put 0 here. U is equal to 2 times 0, right? And that's 0. So when x is 0, u is still 0. X equal to infinity, u is also equal to what? Infinity. So this integral is now equal to this. The integral from u equal to 0 to u equal to infinity of x will now be what? U all over 2. U all over 2 all squared. Okay, I'm replacing x with u all over 2 now. Times e to the power of minus, what is 2x? We said let u be equal to what? 2x. So I have u. Then ds is what? Du over 2. Du upon 2. So this entire integral is what we have here. X is u over 2, then all squared, times e to the power of minus, recall, we said that the entire 2x here is what? Is u. So to the power of minus u, then the x is equal to what? Du over 2. That's what we have here. So let's simplify this. We have the integral from 0 to infinity of u squared upon 4. This is u squared, 2 squared, which is u squared over 4, times e to the power of minus u, all right, into what? Du all over 2. 2 times 4, or 4 times 2 is 8. So I can actually bring 1 all over 8 outside, all right? So the integral from 0 to infinity of u squared e to the power of minus u du. So this integral, if we want to write it like this now, it will be 1 over 8 into the integral from 0 to infinity. T is to the power of x minus 1. So I can write u squared as u to the power of 3 minus 1, because 3 minus 1 is 2. All right. Into e to the power of minus u du. So this integral that we have here looks exactly like what is here. So I can easily say that this is 1 over 8 times the gamma of 3. Yes. Compare this and this. This is t to the power of x minus 1, u to the power of 3 minus 1, e to the power of minus t, e to the power of minus u. Du, they are the same. T, they are the same. dt, du. So this is the gamma of what? 3. Now look at this relation. The gamma function of x plus 1 is equal to x factorial. This must be noted. Just the same way this must be noted, this very relation. So gamma of 3 is gamma of 2 plus 1. 2 plus 1 is equal to 3. So gamma of 2 plus 1, which is gamma 3, is the same thing as saying 2 factorial. What is 2 factorial? 2 factorial is 2, which is the same thing as saying 1 times 2 all over 8. And what's 2 over 8? 1 over 4. So this integral, the integral from 0 to infinity of x squared into e to the power of minus 2x dx is 1 over 4. This is the second question. If gamma of 0.75 is equal to 1.2254, we have to evaluate the integral from 0 to infinity of 2x to the power of 1 over 2 times e to the power of minus x squared dx. This is x squared, all right? 0.75 is 3 over 4. So this is actually gamma of 3 over 4. Okay, so let's see. Now, let's write this integral in the standard form. That is, the gamma function of x, okay, is the integral from 0 to infinity of t to the power of x minus 1, all right, into e to the power of minus t dt. So let's write this integral to look like this. That's what I mean by standard form. Looking at this integral and this, they are not the same. They don't look alike. T here is having a power of 1, all right, but x here is having a power of 2. So we have to make some modifications. So for this integral, from 0 to infinity of 2x to the power of 1 half e to the power of minus x squared dx, I'll say let u be equal to x squared. That's it. Let u be equal to x squared. Making x the subject of the formula, x is equal to u to the power of 1 over 2. If we make x subject of the formula by taking the square root of both sides, this is what we'll have. So let's take note of this. Also, from here, I can differentiate u with respect to x. All right. Du is, differentiate this, we have 2x dx. Making the s the subject of the formula, the s is equal to what? Du all over 2x. So let's also take note of this. So let's rewrite this integral in terms of a new variable u. So this integral will now be equal to this. Take note, the limit will still remain. Yes, the limit will still remain from 0 to infinity. From 0 to infinity. 2 is a constant. I want to bring it outside. So x to the power of 1 over 2. What is x? X is what? U raised to the power 1 over 2. Okay, so this is u raised to the power 1 over 2, or raised to the power 1 over 2, because x is having a power of 1 over 2 here. So I will raise u to the power of 1 over 2 to that same power of 1 over 2, times e to the power of minus, what is x squared? U. What is ds? ds is equal to du all over 2x. Du upon 2. I don't want to write x because the integral is in terms of u. So what is x? Remember we said x is what? U to the power of 1 over 2. So I'm writing u to the power of 1 half. You see the integral now. Okay, so this is 2 into the integral from 0 to infinity of u to the power of 1 over 4. 1 half times 1 half is 1 quarter. 1 over 4 times e to the power of minus u. Okay, let me write this way. 1 over 2 u to the power of 1 half du. Alright, see something. 2 can cancel 2. This is u to the power of 1 over 4. And here I'm having u to the power of 1 over 2. So by the law of indices, I will say u to the power of 1 over 4 minus 1 over 2. Yes, so what would that give me? This is u to the power of 4, 1 minus 2. The LCM is 4. So 4 into 4 is 1. 1 times 1 is 1. 4 divided by 2 is 2. 2 times 1 is 2. So that's equal to u to the power of minus 1 over 4. Then e to the power of minus u du. Looking at the standard form, I call it standard form, the gamma function of x. Okay, t here is raised to the power of x minus 1. That means we'll subtract 1 from a particular number. So what should we subtract 1 from to get minus 1 over 4? Because I want to write this now as u raised to the power something, let's say p minus 1. And this p minus 1 must be equal to minus 1 over 4. So if we form a mathematical equation with that, p minus 1 equal to minus 1 over 4. So we have p equal to, if 1 cross it comes to plus, 1 minus 1 over 4. So 4 times 1 is 4, 4 minus 1 is 3 over 4. Okay, so p here is 3 over 4. So that 3 over 4 minus 1 is minus 1 over 4. So we can write this integral now as the integral from 0 to infinity of u to the power of 3 all over 4 minus 1, which is equal to minus 1 over 4, times e to the power of what? Minus u du. So you can see that this is exactly the form that we have here. You see. So gamma of x is equal to this. Since these two now they are in the same format, we can say that gamma of 3 over 4 is equal to this. Am I correct? Yes. Just observe the pattern. I'm having the integral from 0 to infinity of u to the power of 3 over 4 minus 1 into e to the power of minus u du. So 3 over 4, what is it? 0.75. Oh, this is the reason they gave us the gamma of 3 over 4, which is the gamma of 0.75. So it is very obvious that the gamma of 3 over 4 from what we are given is equal to what? 1.2254. So this integral is equal to this. Let's handle the third question. This question is under beta function. If gamma of 3 over 2 is root pi over 2 and gamma of 5 over 2 is 3 root pi over 4, we have to evaluate the integral from 0 to 1 of x to the fourth into the square root of 1 minus x squared dx. First of all, the beta function of m and n, beta of m and n, is the integral from 0 to 1 x to the power of m minus 1, all right, into 1 minus x to the power of n minus 1 dx. This is the beta function, beta of m and n. So our job is to write this integral in this format. Now, for the integral from 0 to 1 of x to the fourth into the square root of 1 minus x squared dx, it is equal to the integral from 0 to 1 x to the fourth into 1 minus x squared to the power of 1 over 2 dx. You know, square root is equivalent to the power of 1 over 2. Okay. Now, look at something. I'm seeing 1 minus x in brackets, but here I'm seeing 1 minus x squared. So I will have to reduce that or simplify that. So let's introduce a new variable to solve that problem. Let u be equal to x squared. This is the x squared. So from here, x is equal to u to the power of 1 over 2. That's the square root of u. If I take the square root of both sides, okay, I'll get this. From here, if I differentiate u with respect to x, I'll get 2x dx. And so, making the x the subject of the formula, we have the u all over 2x. You get it? We set u equal to x squared. And from here, we made x the subject of the formula. We got this, u to the power of 1 over 2. From here, we differentiated u with respect to x. So du dx is 2x. Cross multiplying du equal to 2x dx. And we made the x the subject of the formula. We got this. When this is x equal to 0, x equal to 1. So when x equal to 0, what is u? If I put 0 here, u is still 0. When x is equal to 1, which is the upper limit, put 1 here. 1 squared is 1. U is also equal to 1. So the limits are still in place. They are still in order. So we can write this entire integral as the integral from 0 to 1. U is 0, u is 1. We are writing the integral now in terms of what? In terms of u, no longer x. So 0, 1, that's what we have here. This is x to the power of 4. What is x? X is u to the power of 1 over 2. So I'm writing u to the power of 1 over 2 or raised to the power of 4 because x has the power of 4 here. Then in bracket, 1 minus x squared is what? Is u. 1 minus u to the power of 1 over 2. And what's ds? ds is what? Du over 2x. Du all over 2. What is x? I don't want to write x. I'll write u to the power of 1 half. You get it? U to the power of 1 over 2. The integrand is now a function of u, no longer x. So this integral is equal to the integral from 0 to 1. Then we have u to the power of 1 over 2 times 4 is 4 over 2, which is 2. Alright, u to the power of 2. Okay, let's simplify these two together. I have u to the power of 1 over 2 here, so I will subtract that power. Okay, then we now have, alright, 1 minus u to the power of 1 over 2. Okay, this is 2u 1 half. So I'm having 1 over 2 here. Then du all over 2. I want to bring that 2 out as 1 all over 2. You get the point? So 1 over 2 is outside. Alright. This is 4 over 2. And that is 2. So if we simplify these two, because they have the same base, using the law of indices, it will be that 2 minus the 1 over 2 here, which is the power of u. So this is it. 1 over 2 into the integral from where? From 0 to 1. 2 times 2 is 4. 4 minus 1 is 3. So we have u to the power of 3 all over 2. Then 1 minus u to the power of 1 half du. We are almost there. Alright, we are almost there. So we are having n minus 1 here. We are having n minus 1 here. So for n minus 1, we are going to subtract 1 from a number to obtain 3 over 2. Look at it. Let's see, we are seeing u is raised to the power of n minus 1. And this n minus 1 must be equal to 3 over 2. So m minus 1 equal to 3 over 2. What is m? M is equal to 1 plus 3 over 2. 2 times 1 is 2 plus 3 is 5 all over 2. So m is 5 over 2. What is n? The same thing. Subtract. This is 1 minus u to the power of n minus 1. N minus 1 must be equal to 1 over 2 here. So n minus 1 is equal to 1 all over 2. If we make n the subject, we have plus 1. 2 times 1 is 2 plus 1 is 3. 3 all over 2. So n is 3 over 2, m is 5 over 2. So this integral is equal to 1 over 2, the integral from 0 to 1 of u to the power of what? 5 over 2 minus 1. You get the point. 5 over 2 minus 1 is 3 over 2 into 1 minus u to the power of 1 over 2 will now be what? 3 over 2 minus 1 based on what is here. Then our du. So it is as simple as this. So it is very obvious that this integral now, if you compare it with this, we can say it is equal to 1 over 2 beta of 5 over 2, comma 3 over 2. Look at it. M, which is 5 over 2 here, n, which is 3 over 2 here. That's what we have here. So what we have to do now is to determine the value of beta of 5 over 2 and 3 over 2. Now, there is this connection between beta function and gamma function. This is it. The beta of m and n is equal to the gamma of m times the gamma of n all divided by the gamma of the sum of m and n. Beta of 5/2, 3/2. Based on this, it will now be gamma of 5/2, all right, times gamma of what? 3/2, all over the gamma of the sum of 5/2 and 3/2. No wonder they said gamma of 5/2 is 3√π/4. Can you see? And gamma of 3/2 is √π/2. So gamma of 5/2 is 3√π/4. Okay, that's 3√π/4 times, and this is √π/2, √π/2 divided by 5 plus 3 is 8. 8 divided by 2 is 4. So the sum of everything here is 4. So we have gamma of 4. And gamma of 4 is 3 factorial, which is 6. I said it earlier. Gamma of x plus 1 is equal to x factorial. 4 is 3 plus 1. So we have what? 3 factorial. And that's 6. So what we have here is 3√π times √π is 3π. By the law of surd, √π times √π is pi. 4 times 2 is what? Is 8. So we have 8 all over. We said that gamma of 4, which is 3 factorial, is what? 6. So we have 3π all over 8 times 6. 2 here is 1, 2 here, 3 here is 1 rather, 3 here is 2. So we have pi. 8 times 2 is 16. So beta of 5/2 and 3/2 is pi/16. What now is 1/2 into this, which is pi/16. So it is very straightforward. Now we can easily get the integral of this, which will reduce to this. 1/2 beta of 5/2, 3/2 is 1/2 times. Everything here is what we have here, pi/16. So this is what? Pi/16. 1 times pi is pi. 2 times 16 is what? 32. So this is the value of the integral. This value of the integral that we reduced to this. So that's the answer to the question. Question 4. If gamma of 3/2 equal to √π/2, we have to evaluate the integral I equal to the integral from 0 to 1 of x squared into the square root of 1 minus x squared dx. This is a beta function question, alright? Remember, beta of m and n is the integral from 0 to 1 of x to the power of m minus 1 into 1 minus x to the power of n minus 1 dx. So let's write this integral in this format. We have I is equal to the integral from 0 to 1 of x squared. Alright, this is 1 minus x squared to the power of 1/2 dx. The square root is equivalent to the power of 1/2. So I can see x here, 1 minus x. X is having a power of 1. But what I'm seeing here is 1 minus x squared. So let's modify the integral. Let's write it. Let's express it in terms of a new variable, which is u, for example. So I'm going to say, let u be equal to x squared. This is the x I'm talking about. So from here now, if I make x the subject of the formula, I'll be having x is equal to the square root of u by taking the square root of both sides. That's u to the power of 1/2. So differentiating u with respect to x here, I have the u equal to 2x dx. Okay. So making the x the subject of the formula, the s is equal to du all over what? 2x. So we can write this integral now as I is equal to, let's ensure the limits are in order. When x is 0, this is x equal to 0, x equal to 1. So when x is 0, put 0 here. 0 squared is still 0, u is equal to 0. When x is 1, 1 squared is 1, so u is equal to 1. So the limits remain. So we are talking about the integral from u equal to 0 to u equal to 1. x squared is u, okay, into 1 minus u, all right, 1 minus u to the power of what? 1/2. What's ds? Du all over 2x, du all over 2x. But x itself is u to the power of 1 over 2. So the integral is this, from 0 to 1. Okay, we have the power of 1 here for u. So by the law of indices, I'll write 1 minus this 1/2. 1 minus 1 over 2, okay, then in brackets 1 minus u to the power of 1 over 2, then I'm having du over 2. Okay, let me bring 1 over 2 outside. That's 1 over 2, this one, then du. So it's correct. U here is to the power of 1. So since they have the same base, we say 1 minus 1 over 2. That's what is here. 1 minus u to the power of 1 over 2 du. So let's simplify. We have 1 over 2 to the integral from 0 to 1 of 1 minus 1 over 2 is 1 over 2, that's half. U to the power of half, okay, 1 minus u to the power of half du. So we have to write this like this. X here is u, x here is u. So what is m and n? That's the next question. What's m and n? We want to write this as u to the power of m minus 1. And m minus 1 must be equal to 1 over 2. M minus 1 is equal to 1 over 2. So what is m? M is equal to 1 plus 1 over 2. 2 times 1 is 2. 2 plus 1 is 3 over 2. So m is what? 3 over 2. That means this will now be u to the power of 3 over 2 minus 1. Because 3 over 2 minus 1 will give us 1 over 2. So m is 3 over 2. What is n? We have 1 minus u to the power of n minus 1. This is what we're looking for. So n minus 1 must be equal to 1 over 2. So if we do the same thing, n minus 1 equal to 1 over 2, we will see that n is still equal to 3 over 2. Because 1 over 2 plus 1 is 3 over 2. So n is equal to n equal to 3 over 2. So this is now 1 over 2 into the integral from 0 to 1 of u to the power of 3 over 2 minus 1 into 1 minus u to the power of 3 over 2 minus 1 u. And this, if we compare this with this, we can say it is equal to 1 over 2 into beta of m is 3 over 2. N is still 3 over 2. So we have 3 over 2, comma 3 over 2. That's what the integral is equal to. So what is beta of 3 over 2 and 3 over 2? Remember what I gave just now. I said beta of m and n is gamma of m times gamma of n all over gamma of m plus n. So they gave us gamma of 3 over 2. Beta of 3 over 2, comma 3 over 2 is equal to gamma of 3 over 2 times gamma of 3 over 2. I'm following this now. Divided by the sum of gamma of 3 over 2 plus 3 all over 2. Alright. So gamma of 3 over 2 is what? Root pi over 2. So we have root pi over 2 times root pi all over 2 all over the gamma of what? 3 over 2 plus 3 over 2 is 6 over 2, and that's 3. And gamma of 3 is 2 factorial, which is 2. Remember I said gamma of x plus 1 is equal to x factorial. And 3 is what? 2 plus 1, which is 2 factorial. That's the gamma of 2 plus 1. Root pi times root pi is pi. By law of surd, 2 times 2 is what? 4. Gamma of 3 is 2 factorial, that's 2. So we have pi all over 8. 4 times 2 is 8. So This now will now be 1 over 2 into beta of 3 over 2 and 3 over 2 is equal to 1 over 2 times this is this pi all over 8, and that's what? Pi over 16. So this is the value of the integral. See the fifth question. We have to find the particular integral for this equation, this differential equation. D square y dx squared minus 5 dy dx plus 6y equal to x squared. Now, this is a second order differential equation. Determining the solution of a second order differential equation that is non-homogeneous, we need the complementary function and the particular integral. All right. So complementary function, that is y sub c. Particular integral, that is y sub p. So if I add the two of them together, I will get the general solution to that particular differential equation. So what I want to do is, I want to quickly run through the process of determining both the complementary function and the particular integral. I'll write the auxiliary equation of this differential equation. So if I replace dy dx with m and d square y dx squared with m squared, I'll be having m squared, okay, minus 5m plus 6 then equal to 0. We call this the auxiliary equation. We set the left hand side to 0 after replacing dy dx with m and d square y dx squared with what? M squared. So I want to solve this quadratic equation now. All right. So I'll be having two numbers when multiplied to give me 6, when added to give me minus 5. Multiplied to give 6, added to give minus 5. The two numbers are minus 2 and minus 3. Minus 2 times minus 3 is 6. Minus 2 plus minus 3 is minus 5. So m squared minus 2m minus 3m plus 6 equal to 0. So let's factorize by grouping in twos. For this first two, m is common. So we have m minus 2. For this last two, minus 3 is common. I'll be having m minus 2 also. So the brackets are the same. Then m minus 3 equal to 0. So it means that m minus 2 equal to 0 or m minus 3 equal to 0. M is equal to 2 or 3. So the complementary function, when the two roots are not equal, m is not equal to 3, 3 is not equal to 2, and they are real roots, they are not complex roots. The complementary function is this. A e to the power of the first, any of them, 2x plus b times e to the power of the other one, 3x. So this is the complementary function actually. Well, I have a video for differential equations, second order differential equation that is homogeneous, so you can learn how to determine complementary function actually. So let me determine the particular integral now. Just watch. Let the particular integral be equal to this. At the right hand side, what do I have? I have x squared. So the particular integral for x squared is actually the polynomial ax squared plus bx plus c. Yes, this a and b, they are different from what is here anyways. This is for y. What is dy dx? Let me differentiate this now. If I differentiate this with respect to x, I'll get 2ax plus b, right? Yes, a and b and c, they are constant. And if I take the second derivative with respect to x, I'll get 2a, just 2a. Differentiate the constant is 0. Differentiate 2ax with respect to x. Here 2a is a constant, it is 2a. So what I will do is, in place of d square y dx squared, I'll write 2a. In place of dy dx, I'll write everything here. So minus 5 into 2ax plus b. In place of y, I'll write this. So plus 6 into ax squared plus bx plus c. Everything is equal to what? X squared. So let me expand. I have 2a minus 10ax minus 5b plus 6ax squared plus 6bx plus 6c equal to what? X squared. Let us determine the constants a, b, and c. All right, by comparing coefficients. I have x squared here. I only have one term in x squared at the left hand side, which is 6a. So if I compare coefficients, 6a, which is the coefficient of x squared at the left, is equal to 1, which is the coefficient of x squared at the right. So 6a is equal to 1. That means a is equal to what? 1 over 6. So I've gotten a already. Okay, let's see again. 2a is a constant. Minus 5b is a constant. 6c is also a constant. So I can say 2a minus 5b plus 6c is equal to what? 0. There is no constant at the right hand side, so we assume it is 0. So the constant at the left hand side, the sum of the constant at the left hand side, is equal to the sum of the constant at the right hand side. And so you're having 0 here. So we can't get b from here. So we need one more equation. This is minus 10a, which is the coefficient of x. And this is 6b, which is also the coefficient of x. There is no term in x at the other side, at the right hand side. So we assume it is 0. So minus 10ax, no, minus 10a rather, plus 6b is equal to what? 0. Since there is no x at the right hand side. We can get b from here because we know that a is equal to what? 1 over 6. So minus 10 all over 6. Since a is 1 over 6 plus 6b is equal to 0. All right. So this is actually 2 here is 5 and 2 here is what? 3. So minus 5 all over 3 is equal to minus 6b. Minus we take away minus. So dividing both sides by 6, so as to eliminate the 6 from here, we'll be having b equal to 5 all over 3 times 6, and that's 5 all over what? 18. So b is 5 over 18. From here now we can get c. A is already 1 over 6, b is 5 over 18. So let's put it here, that's 2 times 1 over 6, 2 over 6. B is 5 over 18. So 5 over 18 times 5 is 25 all over 18. So I want to take 6c to the other side. Okay. The LCM is 18. So 18 divided by 6 is 3. 3 times 2 is 6. 18 divided by 18 is 1 times 25 is 25. 6 minus 25 is minus 19, right? Minus 19 all over 18 equal to minus 6c. Minus take away minus. So if we divide both sides by 6, we'll be having c equal to 19 over 18 times 6. 18 times 6 is 108. 6 times 8 is 48. Put down 0, put down 8, take away 4. 6 times 1 is 6 plus 4 is 10. 108. So 19 all over 108. So we've gotten the constants that we need. What now is the particular integral? So the particular integral is this. What's a? 1 over 6. So 1 over 6s squared. What's b? 5 over 18. And what's c? 19 over 108. This is the particular integral for this differential equation. So if, for example, we are to determine the general solution, that will be y equal to particular integral plus complementary function a e to the power of 2x plus b e to the power of 3x plus 1 over 6 x squared plus 5 over 18x plus 19 upon 108. And this would be the general solution if we were asked to determine it. But for this question, this is the particular integral. In this question, we have to form the differential equation for this equation, and we write the order of the differential equation that is formed. So here we are having y equal to ax plus a squared, a the same thing. Okay, so just differentiate y with respect to x, and let's see what it will produce. Since a is a constant, differentiate this one and we get 0 because it's a constant. A is a constant, a squared is also a constant. Here a is a constant, so differentiate ax with respect to x, we'll get a. So dy dx is equal to a. You know what we'll do? In place of a here, I'm going to write dy dx. So y will now be equal to, in place of a, I'm writing dy dx times x. You get it? Plus a, which is what? Dy dx, all squared. So y is equal to x dy dx plus dy dx all squared. So this is the differential equation that is formed. The next question is, what is the order of the differential equation? There is a difference between d square y dx squared and dy dx all squared. They are not the same. This one shows order, this one shows degree. This is of order 2 because of the square. This is of what? Order 1. All right, and possibly order 3. All right, so second order, first order, third order, and so on and so forth. But this differential equation inside this bracket is of order 1, but it has a degree of 2. Okay, for this differential equation, the order is 1. All right, let's solve this question. We are to solve dy dx plus 1 over xy equal to xy squared using Bernoulli's equation. Actually, this is Bernoulli's differential equation of the first order. A Bernoulli's differential equation of the first order is of the form dy dx plus p of x into y equal to q of x into y to the power of n. So what we are going to do is to reduce this Bernoulli's equation to a linear first order differential equation. This is Bernoulli's equation. This is linear equation I want to write now. Dy dx plus p of x into y equal to q of x. This is the linear differential equation of the first order. So you see that the only difference between the two of them is that there is a y to the power of n here, but here there is no y to the power of n. So we are going to reduce this equation, all right, to a linear first order differential equation. So the equation says dy dx plus 1 over x into y equal to xy squared. So first of all, when solving the Bernoulli's equation, we divide both sides by y to the power of 2. That means we remove this y to the power of n from the right hand side. And if I do that, I'll be having 1 all over y squared dy dx plus 1 over x y all over y squared equal to x. I've divided both sides by what? Y squared. So from here we have y to the power of minus 2 dy dx plus 1 over x. Y divided by y squared is y to the power of minus 1, which is 1 over y. So y to the power of minus 1 equal to x. So what I will do now is introduce a new dependent variable, z, in place of y. So let z be equal to y to the power of minus 1. This y to the power of minus 1 here is what we will set equal to z. The variable that is attached to what? P of x. That's what we are talking about. So if I differentiate z with respect to x, I will differentiate y with respect to x also. You know, if I want to differentiate y to the power of minus 1 with respect to x into the minus 1 times y, which is minus y, then I'll subtract 1 from this minus 1. That will be what? Minus 2 dy dx. So I can see from here, this is a very useful equation. From here now, that I can see y to the power of minus 2 dy dx. And I can see something like that here. But there's a minus attached to this one. So if I remove this minus from here, by dividing both sides by minus 1, the minus will come to this side. Right? So what I will do now is, in place of this, everything here, this first term, I'll put down this. So minus dz dx plus 1 over x, y to the power of minus 1, what is it? Is z. Remember, we are introducing z in place of y, which is equal to what? X. So if I divide both sides by minus 1 to eliminate this minus from here, the z dx is equal to, okay, minus 1 over x, z equal to minus x. So this is a linear differential equation. Linear is of this form, where y is equal to z here. So this is how to solve linear equation. Actually, I have a video for linear differential equation, and I have video for Bernoulli's equation. All right, so you can watch to learn in full, in details, how to solve these two equations and other equations as well, exact equations and others. Okay, so we determine what we call integrating factor. Integrating factor, and integrating factor is e to the power of the integral of p of x dx. Now let's see, compare. P of x is attached to y, right? So what is attached to z here? Minus 1 over x. That will be the p of x here. So this is e to the power of the integral of 1 over x minus 1 over x rather, times what? Okay, dx. Okay, I can bring this minus outside. Okay, so I'll be having, if I integrate 1 over x dx, that's ln x minus ln x. The minus can stand as the power of x. We'll be having e to the power of ln x to the power of minus 1. So e will take away ln. You know, ln is log to base e. So e raised to the power log x inverse to base e, they will cancel out. That's what the law of logarithm says. We are now left with what? X to the power of minus 1, which is 1 all over x. So this is the integrating factor. We will now substitute this integrating factor into this equation. Z times the integrating factor is equal to the integral of the integrating factor times q of x dx. If the dependent variable were to be y, we would have written y here. So it is z, we have to reduce z. We are working with this equation. So z times, what's the integrating factor? 1 over x. So I have z over x. 1 over x times, what's q of x? Here it is minus x. X cancel x. Minus will come out. So I have minus integral of dx. And what would that give me? Minus s. Plus c. The integral is indefinite, so we add the constant of integration to it. So making z the subject of the formula, z is equal to, use s to multiply through, that will be cx minus s squared. Recall that z is equal to y to the power of minus 1. You know, we are solving this equation and not this. This is not the equation we are solving. Okay, this is the equation that we are solving. This is Bernoulli's equation. We only reduce the equation to a linear equation that is easy to solve. So we are now replacing the variables. That's what we are doing now. So recall that z is equal to y to the power of minus 1. So I want to write that now here. So we'll be having y, okay, y to the power of minus 1 equal to cx minus s squared. and this is 1 over y equal to cx minus s squared. If I reciprocate both sides to make y the subject, y will be equal to 1 all over cx minus s squared. This is the solution of this Bernoulli's equation. This is the general solution to the equation. So this is what we are actually solving for. I hope you enjoyed the video. Keep supporting by subscribing to this channel. Like and share the video to your friends and to your classmates. Alright?